to a story with origins many centuries ago. Scientists have recently unraveled the genetic code of the Black Plague.
For 675 years, we blamed the wrong animal. The Black Death killed 200 million people. It wiped out half of Europe in just 8 years, and everyone blamed the rats. Dirty, flea-infested rats spreading plague through medieval cities. That's what the history books say. That's what scientists believed. But in 2022, DNA evidence finally revealed the truth. And it changes everything we thought we knew about the deadliest pandemic in human history. Here's what nobody tells you. The Black Death didn't start with rats, and it didn't spread because of rats either. The real story is so much more disturbing. In 1880, a team of Russian archaeologists arrived at a remote cemetery near Lake Issyk-Kul in what is now Kyrgyzstan, Central Asia, the Tian Shan Mountains, middle of nowhere. The expedition was led by a man named Nikolai Pantusov, a Russian military officer and archaeologist exploring ancient burial sites along the old Silk Road. What they found was unusual. 118 bodies, all buried in a very short time period, between 1338 and 1339. Now that might not sound significant, but think about it. In a small medieval trading community, you'd expect maybe 5 to 10 deaths per year. Natural causes, old age, childbirth. But 118 deaths in 2 years? That's a catastrophe. And the tombstones told a story. They were inscribed in Syriac, an ancient language used by Christian communities along the Silk Road. The inscriptions were detailed: names, dates, professions. This is the tomb of the believer Sanmak. He died of pestilence. Another one, in the year 1649, that's 1338 CE in our calendar, died of pestilence. Again and again, the same word, pestilence. The Russian team carefully documented everything. They photographed the tombstones, drew maps of the cemetery layout, measured skull dimensions, and then they packed up the bones and shipped them 3,000 miles west to the Peter the Great Museum of Anthropology in St. Petersburg, where they sat, in storage, for 140 years. Nobody knew what killed these people. Pestilence was a catch-all term in the Middle Ages. It could mean anything: cholera, typhus, smallpox. Without germ theory, people didn't understand what was killing them. They just knew it was fast and brutal. So the bones collected dust in a Russian museum, while the Black Death remained one of history's greatest mysteries. Where did it come from? How did it spread so fast across 3 continents? Why did it kill so many people? Historians had theories. Some said it came from China. Others said India. Some pointed to the Middle East. But nobody had proof. And then, 140 years after those bones were excavated, a historian named Philip Slavin was sitting in his office at the University of Stirling in Scotland. It was 2020. The middle of the COVID-19 pandemic. And Slavin was doing what historians do during lockdown. Digging through old documents. He was researching medieval trade routes, economic records, burial patterns, and he stumbled across something that made him stop. The excavation records from Lake Issyk-Kul, the 1880s Russian expedition. Slavin started reading through the burial dates, and he noticed something strange. In the years 1337 and earlier, the cemetery had maybe 5 to 8 burials per year, normal mortality for a small community. But then in 1338, the number spiked, 65 burials, and in 1339, another 53. A massive spike. Slavin's heart started racing, because he knew the Black Death hit Europe in 1346. 8 years after this burial spike in Central Asia. Could this be connected? He looked at the location. Lake Issyk-Kul sits right on the Silk Road. the major trade route connecting China to Europe. Caravans passed through this region constantly, carrying silk, spices, precious metals. And if a disease jumped to humans here in 1338, it would have spread west along those trade routes, slowly, town by town, caravan by caravan, taking 8 years to reach the Black Sea, where it exploded across Europe in 1346. The timeline fit perfectly. But Slavin needed proof. He needed to know what killed those 118 people in 1338. Were the tombstones accurate? Was it really plague? Or just some other medieval disease that got called pestilence? Slavin reached out to 2 geneticists at the Max Planck Institute in Germany, Maria Spyrou and Johannes Krauss, experts in ancient DNA extraction. And he asked them one question: those bones, sitting in a museum in St. Petersburg for 140 years, can you extract DNA from them? Here's where it gets interesting. Ancient DNA is hard to work with. After a person dies, their DNA starts degrading immediately. Bacteria break it down. Environmental factors destroy it. After 700 years, most DNA is gone. But there's one place in the human body where DNA survives longer than anywhere else: the teeth. Specifically, the pulp inside the teeth. When someone has a bacterial infection in their bloodstream, like plague, the bacteria get trapped in the dental pulp. And when the person dies and the soft tissue decays, that bacteria's DNA gets preserved inside the hard enamel shell of the tooth, protected, sealed, waiting. So in 2021, Maria Spyrou and her team traveled to St. Petersburg. They gained access to the museum's collections, and they selected skulls from 7 individuals, all buried in 1338 or 1339, all with tombstones that mentioned pestilence. Using dental drills, they carefully extracted samples from the teeth, tiny amounts, just a few milligrams. The DNA inside was fragmented, broken into millions of tiny pieces. But using cutting-edge sequencing technology, they could reassemble those fragments, like putting together a jigsaw puzzle where 99% of the pieces are missing. It took months, sample after sample, sequence after sequence, and then they found it. In 3 of the 7 individuals, Yersinia pestis, the bacteria that causes plague. We could finally show that the epidemic mentioned on the tombstones was indeed caused by plague, Slavin said in the published paper. These weren't victims of some random medieval disease. These were the first known victims of the Black Death. 8 years before, it devastated Europe. But they didn't stop there, because identifying the bacteria was only the beginning. They wanted to know where this strain came from, so they sequenced the entire genome of the ancient bacteria, all the genetic code, every mutation, every variation. And then they compared it to a database of modern plague strains from around the world, strains collected from rodents in Kazakhstan, Mongolia, China, Russia, Africa, the United States. Hundreds of different plague samples, all mapped onto a genetic family tree showing how they evolved over thousands of years. And when the researchers placed the 1338 strain on that tree, they couldn't believe what they were seeing. This strain from Kyrgyzstan, from 1338, sits at the exact node of what scientists call the Big Bang of plague diversity. Here's what that means. All plague bacteria mutate over time, creating a family tree. Scientists knew there was a massive diversification event where one ancestral strain split into 4 major lineages. Those 4 lineages still infect rodents worldwide today, but nobody knew when or where this happened, until now. We found that the ancient strains from Kyrgyzstan are positioned exactly at the node of this massive diversification event, Maria Spyrou said. we found the Black Death source strain, and we know its exact date, 1338. This is the mother of all plague strains. Every outbreak from the 14th century to today traces back to this community. Now here's the question that changes everything. Where did this strain come from? Did it evolve locally, or was it brought in from somewhere else? The answer is in the mountains. The researchers analyzed modern plague strains from rodents across Central Asia, and they found that the strains most closely related to the 1338 bacteria are found in plague reservoirs around the Tian Shan Mountains, the exact region where Lake Issyk-Kul is located, which means the plague evolved locally. Right there, in the mountains of Kyrgyzstan, but not in rats, in marmots, gray marmots, large rodents that live in mountain burrows. Marmots have carried plague bacteria for thousands of years. It lives in their populations naturally, without killing them all. A reservoir. And in 1338, something happened. Climate change. A warm, wet period. Surge in marmot populations. More marmots meant more fleas. More fleas meant more opportunities for the bacteria to jump to a new host. Humans, the trading community near Lake Issyk-Kul, hunted marmots. They used marmot skins for clothing and trade. One infected flea. One bite. And the bacteria entered the human population. 118 people dead within a year. But that was just the beginning. Because Lake Issyk-Kul wasn't just some remote mountain village. It was a major stop on the Silk Road. Caravans traveling from China to Europe passed right through this region. And when the plague jumped to humans in 1338, it hitched a ride west, slowly, over 8 years, from host to host, town to town, caravan to caravan, until 1346, when it reached the Black Sea port of Kaffa and exploded across Europe. Now here's where the story gets truly disturbing. Everyone assumes rats spread the plague once it reached Europe. That's the narrative we've all learned. Rats on ships. Rat fleas jumping to humans. Disease spreading through rat-infested cities. It's in every textbook, every documentary, every historical account. But when you actually look at the evidence, it doesn't add up. First, the speed. The Black Death spread across Europe faster than any rat-borne disease possibly could. Let me give you specific examples. In Messina, Sicily, the plague arrived in October 1347 on ships from the Black Sea. Within 3 months, it had spread 800 miles north to Pisa and Genoa. That's 9 miles per day. Through medieval terrain, across mountains, in winter. If rats were the primary vector, the disease would have to jump from rat to flea to human. That's a slow process. Rats have to get infected first, then die. Then their fleas jump to new hosts. It takes weeks for that cycle. But the Black Death moved like wildfire, faster than rats could carry it. In some cities, it killed half the population in a matter of weeks. Physicians at the time wrote about how quickly it spread. One day, someone is healthy. The next day, they're covered in buboes. 3 days later, they're dead. And everyone around them starts getting sick immediately. That's not rat transmission. That's human to human. Second, the season. Here's something that should have tipped scientists off decades ago. The plague ravaged northern Europe through the coldest months of the year. In England, historical records show the plague arrived in June 1348. But instead of peaking in summer and dying down in winter, it got worse. The death toll peaked in spring 1349. After spreading all through the winter months, in London specifically, parish burial records show the highest mortality in March and April 1349, after one of the coldest winters on record. Now, here's the problem with the rat theory. Rat fleas. The species Xenopsilla chiopus have very specific environmental needs. They thrive in temperatures between 10 and 25 degrees Celsius, and they need relatively humid conditions in freezing medieval winters, with temperatures well below 10 degrees. Rat fleas become dormant. They stop feeding, stop reproducing. Many die, so if rat fleas were spreading the plague, you'd expect the epidemic to slow down or stops during winter, then flare up again in spring when temperatures rose. But that's not what happened. The plague spread continuously, through snow, through ice, through the coldest months, without pause. Third, the archaeology. This is perhaps the most damning evidence against the rat theory. If rats were the primary cause of the Black Death, you'd expect to find massive rat die-offs in the archaeological record. Think about it. Rats would get infected first, before humans, and plague kills rats quickly. So there should be layers upon layers of dead rats in medieval trash heaps, building foundations, cesspits. Archaeologist Barney Sloane spent 10 years excavating medieval London's waterfront, areas where rats would have been abundant: docks, warehouses, grain stores. He analyzed thousands of layers of medieval debris, and he found almost no evidence of mass rat mortality. There is insufficient evidence of the extinction of numerous rats, he wrote. A few rat bones here and there, normal levels, but no catastrophic die-off coinciding with the plague years. In York, similar excavations. Same result. In Paris, in Venice, in Marseille. Everywhere archaeologists look, the rats aren't there. Which leads to an obvious question. If the rats didn't die, how were they spreading a disease that was killing millions of humans? Fourth, the mortality pattern. When plague is spread by rats, it follows a specific pattern. The disease starts in poor, rat-infested neighborhoods, then slowly spreads to wealthier areas. Because rats concentrate where there's garbage, poor sanitation, overcrowding. But during the Black Death, that's not what happened. The plague struck everyone simultaneously. Rich nobles in their castles, poor peasants in their hovels, priests in monasteries, kings, queens, bishops. It didn't discriminate by location or social class. That pattern is consistent with human-to-human transmission, not rat-to-human. So if not rats, then what? In 2018, researchers Catherine Dean and Boris Schmid from the universities of Ferrara and Oslo built sophisticated mathematical models, computer simulations of how diseases spread through populations. They programmed 3 different transmission scenarios. Scenario 1. Rat fleas. Disease jumps from rats to fleas to humans. Scenario 2. Airborne transmission. People breathe in infected droplets. Scenario 3. Human ectoparasites. Fleas and lice living on people. Then they ran these models against actual mortality data from 9 different European plague outbreaks. Cities where detailed death records survived, parish registers, burial records. And they asked the computer, which model fits the real data best? The result was shocking. In 7 of those 9 cities, the human ectoparasite model fit the mortality patterns better than rat transmission. Not just slightly better, significantly better. The plague was spread from human fleas and body lice to other people, the researchers concluded. Person to person, direct transmission, no rats required. Now let me paint a picture of what medieval Europe was actually like. We're talking about cities where 50,000 people might be crammed into 1 square mile. No running water, no sewage systems, no concept of hygiene. People wore the same clothes for weeks, months even. They rarely bathed, maybe once or twice a year. Wealthy nobles might bathe more often, but common people? Almost never. And in that environment, body lice were universal. Every single person had them, crawling in their hair, living in the seams of their clothing, feeding on their blood constantly. Human fleas, too. The species Pulex irritans. They lived in bedding, in straw mattresses, in the rushes on floors. When someone got infected with plague, Yersinia pestis entered their bloodstream. Their body lice and fleas would feed on that infected blood, and the bacteria would multiply inside the parasite's guts. Then those lice and fleas would jump to the next person. In shared beds, in crowded homes where multiple families lived in one room, in churches where people packed together for services, in marketplaces, in taverns, in public baths, the parasites moved from person to person, continuously, rapidly, unstoppably. And here's why it was so deadly in winter. Rat fleas die in cold weather, but human body lice? They thrive. Because they live inside clothing, against warm skin. They're protected from the cold. In fact, people wore more layers in winter, which meant more places for lice to hide. Heavier wool garments, fur-lined coats, multiple tunics, all rarely washed, all infested with parasites. So while rat fleas went dormant in November, human lice kept spreading plague through December, January, February, March. Non-stop. That's why the plague spread through winter. That's why it moved so fast. That's why everyone got sick, rich and poor alike, because everyone had lice. Now here's the most terrifying part. The plague never went away. After the Black Death ended in 1353, it came back. The Great Plague of London in 1665, the Marseille Plague of 1720, the Plague of Milan, wave after wave, for 400 years. And scientists couldn't figure out why. If rats were carrying it in Europe, why didn't it just become endemic? Constantly present? The answer? Because rats weren't the reservoir in Europe. The plague was being re-imported from Central Asia. Studies have shown a clear pattern. Every 15 to 20 years, after warm, wet periods in the Tian Shan Mountains, marmot populations would surge. The bacteria would spill over to humans again, and caravans on the Silk Road would carry it back to Europe. Over and over, a repeating cycle, until the Silk Road trade routes finally declined in the 1800s. Let me put this in perspective. We've been blaming rats for 675 years, building entire disease transmission models based on rodents. And the whole time, the real culprits were marmots in Central Asia and lice on human bodies. The DNA evidence is undeniable. June 2022. Published in Nature. Maria Spiro, Philip Slavin, Johannes Krause. The source of the Black Death in 14th century Central Eurasia. DNA extracted from the teeth of people who died 687 years ago. Lake Issyk Kul, Kyrgyzstan. 1338. The Tian Shan Mountains. Marmots, not rats. But here's what should terrify you. The plague is still out there, in those same marmot populations, those same mountain reservoirs. The WHO reports 1,000 to 2,000 cases every year. In Africa, Asia, the Western United States. The mortality rate is 8 to 10% with antibiotics. Without treatment? Fatal. And all modern strains trace back to that 1338 outbreak. The mother strain is still alive, still in marmots, still capable of jumping to humans, and climate change is making marmot populations surge again. Warmer temperatures, wetter conditions, the exact factors that triggered 1338. Scientists have proven the correlation between warm, wet weather in Central Asia and plague outbreaks. It's happening right now. Imagine if a drug-resistant strain evolved. We haven't seen antibiotic-resistant plague in 26 years, but it's possible. And with modern air travel, it wouldn't take 8 years to reach Europe. It would take 8 hours. This isn't ancient history. This is a warning. The Black Death killed 200 million people. It shaped the world we live in. And for 675 years, we told the wrong story. But now we know the truth. Mountains of Central Asia, marmots, person to person through lice and fleas. The DNA doesn't lie. So here's the question. If we got the Black Death wrong for nearly 700 years, what else are we getting wrong about pandemics? What other diseases have we misunderstood? Because we're looking at the wrong host? In 2020, COVID-19 taught us how fast a pandemic can spread, how quickly the world can shut down, how unprepared we really are. The Black Death killed 60% of Europe in 8 years, with medieval medicine and no understanding of germs. What would it do today, with air travel and global cities? Let us know your thoughts in the comments below. And if you want more hidden history that changes everything you thought you knew, make sure to like this video and subscribe. Because the truth about our past is often more disturbing than we ever imagined.